they'll just work through the practice test. All I've done is I've just went to the practice test on Hawks and printed out a version. So these will be the same types of problems that you have in Hawks, but the numbers will probably be different on all of them than on yours. Okay, but you'll have an example of how to do all the ones on the practice test. Okay, when we get done with this. Number one, we've got a sequence. Tells us to figure out the missing numbers and then decide if it's one of our special ones, if it's arithmetic or geometric. What are you thinking on the either the next numbers or what kind of rule we're using? Yeah, looks like we're subtracting 20. Get from 30 to 10, we subtract 20. The next one's a little bit harder to see because we go from positive to negative. But, yeah, we're subtracting 20. We don't necessarily have to write that part down, but we do need to think about it. So if we subtract 20, we'll get negative 50, and then subtract 20 again, we'll get negative 70. So if we're subtracting 20 every time, our second part we got to think about, is it arithmetic or geometric? Do you remember which one's which? This one's arithmetic, so if you're adding or subtracting the same number every time, it's arithmetic. So that's this one. Okay. Oh, there's that one. Let's see, number two. Same thing, but we've got a different sequence. Numbers are a little bigger here, so a little bit harder to see. Got the sign-in sheet coming to you. Anybody see it? Yeah, dividing by 2. Dividing by 2. And if that's hard for you to see, if the numbers are a little too big for you to see that, like maybe here you could see it looks like maybe we're dividing by 2, and then you could check it right with your calculator here to make sure. So we're dividing by 2. So 32 divided by 2 is 16. And 8. So here's our rule. And if we're dividing by 2 every step, what kind of sequence is that one going to be? That one's geometric. Yeah, good. If we multiply or divide by the same number over and over, it's geometric. And if we have anything else, any other kind of rule other than the first one and the second one, right, either adding or subtracting or multiplying and dividing by the same number, then it's neither, right? It would be neither. Questions on those two? No? Okay, number 3. Probably may have given you a little trouble when you're into it the first time. Hopefully it's easier this time around. Okay. All right. Yeah, there's not necessarily a shortcut. Like, you can be maybe really clever and come up with like a system of equations and do it that way, but I think for this class our best bet's just trial and error, okay, or guess and test. So we've got 31 heads, 88 feet in a field of cows and chickens. Okay. So the idea there, we're kind of making some assumptions. We're making an assumption that the cows and the chickens only have 1 head each. Okay. You never know. And we're making that assumption, and then we're assuming all the cows have 4 feet and all the chickens have 2 feet. Ask us how many of each animal we have. So the way I start these, some of you I've talked about it with, some of you I haven't. The way I start these is I look at the heads number, so that's telling us how many total animals we have. And then I just pick some combination of cows and chickens that'll add up to 31 in this case, and see how many feet that gives me. Okay. If you want to take a little time and try to make an educated guess here, you can. I usually just shoot somewhere in the middle, so maybe like 16 cows and 15 chickens, and see where that gets me. So there for cow feet, and we multiply by 4, that's 64. And for chicken feet, multiply by 2, so that gives me 30. And if we add those up, I get 94. So I've got too many feet. I'm not too far off though. I'm trying to get to 88. So yeah, so if we have too many feet, we need to decrease the cows, increase the chickens. Okay, so on this one, we're maybe not super close, so I guess I'll change it to 14 cows. And then that would make us have 17 chickens. Let's see how we end up there. That would be 56 cow feet, 34 chicken feet. That comes out to 90. We're getting closer, so that one's pretty close. So I'm gonna just decrease the cows by 1. And then the chickens increase by 1. So we'll go to 13 cows and 18 chickens. So let's see, that's 52 cow feet and 36 chicken feet. Then we end up with 88 feet. Okay. So we've got 13 cows, 18 chickens, just trial and error. That didn't take too long. What, we had to make 3 guesses? Sometimes you get unluckier. Sometimes your first guess is way off and you can adjust a little bit, but usually doesn't take too long to get those. And that's a perfectly valid way of solving the problem. Nothing wrong with that. Okay. Questions on that one? All right. Number 4, get some set questions here. It tells us to write the set using the roster method. So it's written out in set builder notation. It wants us to rewrite it in the roster method. So I know it's set A, so I'm gonna go ahead and get set up. I'm gonna call it A and then put my equal sign in my bracket to get ready. Okay. And it says set A, the set of x's such that x is an even number and x is between 19 and 29. Since we have the equal to bars on there, if 19 and 29 fits in with the other one, we would include 19 and 29. On this one, 19 and 29 don't fit in because we're dealing with even numbers. So our next even number would be 20, 22, 24, 26, 28, and 30 would be too big, so we're done. Our set in roster notation. Bless you. I always do a double too. Are you always 2 sneeze person? Yeah. Usually you have some number that is your normal number of sneezes. I don't know why, but yeah, some people get unlucky and theirs is like 7 or something like that. That's rough. Yeah. Okay. Number 5 says determine the cardinal number of the set, and just a reminder, cardinal number is the one that looks like absolute value. And what does cardinal number mean? Yeah, that's how many we got in there, so we just have to count. So I started to say it makes it easy, but they're not in order. We're missing some. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in there. Our cardinal number is 10. That's really like a vocabulary problem. Just see if you remember what cardinal number is. Okay. Number 6. Let's see what we got coming up here. Number 6. And I have another vocabulary type question. It gives us two sets and asks us, is set P equal to set Q? Why or why not? So have to remember the definition of equal when we're working with sets. In order for two sets to be equal, they have to have exactly the same elements. So would these two be equal? Ooh. I'm sorry. Yeah, we're on 6. Yeah. Yeah, so P's got piano, guitar, drums, flute, oboe, violin. No, because Q says it's the set of all X's such that X is a musical instrument, so which one's going to be a bigger set? Q is going to be bigger, right? Because there are other musical instruments other than just the 5 or 6 that are in P there. Uh-huh. P, yeah.
Does list all those.
It would be yes if they were the same. I mean, if it listed everything that was in the other one, yeah, they would be the same. But on this one, like you can come up with some musical instrument that would be in Q that's not in P. So here we would say no, and maybe you could say or more elements or more instruments in Q. Something like that. Other questions on that one? I'll try to have, if we have, comparing two sets, I'll try to make it some context that's common knowledge. Sometimes some of the examples get kind of specific, something not everybody would necessarily know. So, if you have questions on test A, ask, especially if it's something like, well, I'm not sure if these are all the musical instruments or something like that. Yeah. 7. What I'm thinking of is I'll try to avoid geography, because I think one that popped up in the homework some was like one of them was all the states that started with some letter, and then you have to really think. You almost need to look up a list to make sure that's all of them. So. All right, 7 gives us set A, P-A-R-K-I-N-G, and then our universal set, the letters in the alphabet. It says find a tick mark. So what's the little tick mark mean again? Yeah, it's everything that's not in A, or it's the complement, okay, called the complement. So this one's a little long. I'll try to make it shorter on test day. So what I'm going to do is I'm going to mark out the ones that are in A. So there's A, P, R, K, I, N, E. So then A complement everything else. So be looking for it. If you have one with alphabet, I'm probably, for the universal set, I'll probably like only give you like A through O or something like that. That way you just don't have as much to write down. It's too easy to accidentally skip over one. And that's a silly thing to lose points over because we're not in alphabet class, we're in math class. If you know what the complement is, I want you to get all the points. All right, number 8, same thing, but we're dealing with a Venn diagram. It says list T complement. So we want everything except what's in T. And so we want the ones in S and the ones that are outside. So T complement. It doesn't matter what order you write them in. I'm going to write the ones in S first. And then the ones outside. You can put them in any order. Yes. T complement. Okay. Number 9, maybe something we need to refresh our memory on. Says the set N contains the top full service restaurants of 2015, according to ACSI's annual restaurant report 2015. If set N equals all others, Texas Roadhouse, Longhorn Steakhouse, Cracker Barrel, Olive Garden, Outback Steakhouse, Applebee's, how many proper subsets does N contain? So to figure out anything about subsets, the number of them we're going to have, we need to count how many elements we have in our set. So here we've got 1, 2, 3, 4, 5, 6, 7 elements. Okay. So we could, I'm just going to make a note here, the cardinal number is 7. Bless you. Then how do I get proper subsets? You may remember. Yeah, so our formula, and it's 2 to the n minus 1, where n's our cardinal number for proper subsets. So we'll do 2 to the 7th minus 1, 127. If it just said subsets and not proper subsets, we don't have to do the minus 1. Because what we're doing when we're subtracting 1 off is we're subtracting the possibility off that our subset is the same as our original set. So if we don't want to include that possibility, then we do proper subsets and take that one away. So that's the difference. Sometimes we care that we're not doing the same set itself, and then sometimes we don't. Okay. Questions on that one? Other? Okay. Do some set operations then. Number 10 says find A, and then what's our symbol? And one that looks like a U is union, okay, B. And then what does that mean? Okay, if we're taking the, yeah, we want all of them in there. So if we're taking the union, any element that's in either set is going to be in the union. We don't have to do them twice if they're in there twice. Just anything that's in either set. So 3, 4, 5, 6, 7, 8, 9, 11, 13. Yeah. So just really just combining the two sets together. Okay. And on 11, it says find A, it's the opposite direction, so this one's A, intersect B, intersection of A with B. So how do we know which elements are in that set? If it's in both sets, then it's in the intersection, that's right. So it has to be in both to be in the intersection. So let's see, 2 is in both sets, 4 is in both sets, 6 is in both, 8's in both, and I think that's it. And if you're doing these on tests, feel free to, you can mark through them, whatever you want to do to keep track. So sometimes silly little things like that really help cut down on mistakes. So. Okay, 12, still doing the same operations, but we've got new sets and we're doing more than one operation. Okay? Remember, we're just gonna do one at a time, one operation at a time. And since we've got parentheses on this one, we're gonna start with that. So we'll do B intersects C first. So that's a new set we have to make. We need B intersect C. As far as like, do we do the union or the intersection first? Or C, like C intersect B is the same as B intersect C. Is that what you mean? Yeah. No, so if you're just doing an intersection or just doing a union, you can switch the two sets. It doesn't matter. Yeah. But no, how you list the elements, that doesn't matter. So. Well, no, you could write the union on the other side. The important part on the order on this is that B intersects C's in parentheses. So we got to start with the parentheses, right? And then do the other one. Yeah. Okay. So B intersects C, you're looking at these two. So intersection, we want the elements that are in both sets. So let's see, C is in both, O is in both. I think that's it. Oh, S. Okay, thanks. Yeah. Okay. We good on that one now? I would have missed a little bit of credit on that one. That's now we take our new set and we're going to do the union with set A. So we're using this set and this set and doing the union. So we want A union B intersects C. So doing the union, I'm just going to write down the three in my new set, COS, and then anything I'm missing out of A, I'll put it in there. So I need P, I don't have R yet. I already have O. I need D, I need U. I already have C, and I need T. If you've got another method, that's fine. But again, they don't have to be in any particular order, so as long as they all get in there. Questions on that one? Good to go on that one? Okay. 13. Got a survey. This is a survey of 800 nurses. Yielded the following information. 569 were health club members. 430 were smokers. 325 of the health club members were smokers. How many of the 800 surveyed nurses were health club members or were smokers? You can do this one with a Venn diagram, or you can do it with the inclusion-exclusion principle. It doesn't matter which way you do it. I like having a sketch, so I'm going to do Venn diagram. I'm going to call this one smokers, this one health club members. So let's see, we had 325 goes in the middle because it says 325 of the health club members were smokers, so that means they were both. 325. And then to fill out the rest, we're going to have to do some subtraction. So it says 569 were health club members, so 569 is what we need the H circle to total up to. So we'll subtract 325, 244. And then it says 430 were smokers, minus the 325 that are already in there, get 105. And then on our question down here, it says how many were health club members or were smokers, and that it's or, so it's okay for them to be both, inclusive or here. And so we just add our three numbers up. So what does that give us? 674. That was 105 plus 325 plus 244. Because on this part it says 325 were health club member, 325 of the health club members were smokers. That means they were health club members and also smokers. So that has to go in the overlap. Right? In the places where the health club and the smokers overlap. And then these other numbers that give us, like the 569 for health club members, that's going to be the total H circle. So that's why we have to subtract. So forward. What else could it have asked us? Another good question it could have asked us on this one were how many of the nurses were neither health club members or smokers? So then we would have had to have gone one more step because it told us there were 800 total nurses. We had 674 in here. So we'd have to do the 800 minus the 674 to figure out how many were neither. That would have been a good question they could have asked us also. Questions on that one? If you do the inclusion-exclusion principle, it's the same process, it's just without the picture. Because we would take 569 plus 430 minus the ones that were in both, 325, and you get the same number. Either way works. Let's see, 14. Somewhere here must be the end of the page. Been a little goofy here. All right. 14 says, which of the following is not an example of a mathematical statement? So what do we need to be a mathematical statement? We need to have a value of true or false, not both. So our two big things that are not mathematical statements are opinions and paradoxes. Okay, so A says Michael Jordan's basketball jersey number was 11. Is that one a mathematical statement? It is. Okay, it's false. Okay, jersey number is 23, but it's still a mathematical statement. Okay, so not this one. B says nobody drives on Highway 16. There's too much traffic. Yeah, that one's not because of, if it just stopped at the first part, then you could make an argument, but saying there's too much traffic, that's an opinion in this case. Okay. So that makes that's the one that's non-mathematical statement, but we should check the other ones too, just to make sure. You know. C says my boyfriend is taller than I am. That's either true or false. So that would be a mathematical statement. And then D says this milk has no chocolate in it. That's either true or false, so that one is a mathematical statement also. Just read the question carefully on those because sometimes it asks you which one's not a mathematical statement. And sometimes it says which one is a mathematical statement. So just take your time on that. Questions on 14? 15 tells us to express the given compound statement in symbolic form. So our compound statement is I like green eggs and ham. We're given basic statements I like green eggs, M, and then N is I like ham. So for the first part, we need M, I like green eggs. Then we need and. What's the and symbol? Yeah, it's like a capital A without the bar, right, or upside down V. And then we're kind of changing the wording a little bit here, but that's okay. It's the same meaning because we want I like ham. See? So okay, technically we're saying I like green eggs and I like ham. That's okay. It's the same meaning. 16, uh-oh, it split it up and here's the whole thing. So you can see it all at once. It says use the given simple statements to write the compound statement in words. Okay. So we start off with squiggle B. The squiggle means negation. Okay, sounds good to me. So if we negate B, B is I recently ate lunch. Yeah, so we'll say like I did not or didn't recently eat lunch. That's our negation of B. And then yes, our symbol there, the V symbol is or. And then we just need statement A. It's a weird, we end up with a weird statement, but that's okay. Oh, sorry. I looked at the same thing. I am hungry. Is this not as weird as I thought it was? Did not recently eat lunch or I'm hungry. I'm gonna just go in the other direction. Okay. 17 says us to complete the truth table. So 2 things we need to know on this one. We need to know that that V symbol means or, and then we need to know how to figure out truth values for an or statement. So for or, it's a couple of ways you can think about it, but it's only false if both statements are false. Or you could say it's true if any of the statements are true. You can think about that too. But here, the one I pick out and with an or statement is the 2 false statements down at the bottom. That's the only time an or statement is going to be false. So for the other ones, true, 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 false, false, true, those are all going to be true.
So going like, if M was, okay, it's like the second one first. If M was true and N was false, what would the third one be?
Yeah, so it's like if M was true and N was false, what's the whole statement? The statement as a whole, what's its truth value? That's be true. Or N. Yep. Yep. Okay. What about and? If we have and, what would our rule be then? The and statement is only true when, remember? When they're both true, yeah. So if this was an and statement, the only time it would be true is if they're both true and the other ones would be false. Questions on that one? 18. Get into some of our stuff from that last section. It says, given the statement, if I get $100 for Christmas, then I will be able to buy a laptop. We want to know is the statement, if I do not get $100 for Christmas, then I will not be able to buy a laptop. The converse, inverse, contrapositive, or biconditional. So what have we changed from the original to the new one? Yeah, we put a not in both statements, right? We negated both statements. So if we negate both sides, so we started out with if P then Q, and then now we have if not P then not Q. So which one is that? You can make a guess. You got 25% shot. Really, you should have better than that because we know it's not biconditional. Biconditional is if and only if. It's the inverse. Good. Inverse. So the converse is if we switch the order, if Q then P. The inverse is if we negate both, if not P then not Q. Contrapositive is if we do both things, if we switch them and negate them. So if not Q, then not P, which is contrapositive. And then biconditional is P if and only if Q. So make sure to look over those. This one's the same type of question, but it's worded a different way. This one says, given if it is my birthday, then my mom cooks lasagna for me. Which of the following is the inverse for this statement? So to get to the inverse, what do we want to do? We want to negate both statements. So let's see. Yeah, it looks like B. So there, the only difference from what we're given is the nots on both sides. And if it is not my birthday, then my mom does not cook lasagna for me. So that is the inverse. What is A? A, we've switched the order and negated. So A would be the contrapositive. C says if and only if, so this would be biconditional. And D, we've just switched the order, so D would be the converse. Okay. And 20 just gives us symbols doing the same thing, but it's just symbols. It says find the converse of if P then Q. The converse, we just switch the order. So if Q, then P. A little arrow means if then. It's a conditional statement. Here its implication is really what it means. It means Q implies P, but the way we read it is if then. Okay. Number 21. You'll see if you haven't really noticed that arrow symbol before, you'll see it a bunch of places now where people are saying something implies something else. Probably a lot of your teachers use it when they're doing shorthand for stuff. 21 says use De Morgan's laws to write an equivalent statement without using parentheses. So we're just distributing the squiggle on this one. Okay. So how do we negate this thing in the parentheses? So if we distribute the squiggle, we would squiggle the first one, flip the sign in the middle, squiggle the second one. Okay. And that's technically correct. Or if we kind of wanted it simplified, the two squiggles, we could say those cancel out. And on this particular one, it doesn't say like do the simplest form or anything like that. So either one of those is okay. Questions on that one? Last one. Paying $2.36 in postage to mail a CD. Seems expensive. You thought about that? He uses 43-cent stamps and 8-cent stamps. How many of each stamp did Ben use? So this one's really similar to the farm animals problem. Okay. This one that's just good to use guess and test on. You can be a little methodical about it. Usually on this one way I get started is I'll take the $2.36, so 2.36, and divide it by whatever the big stamp is. So here it's 43 cents, so I'm going to divide by 0.43. And if I do that, I get 5 point something. So I know that I can't use any more than 5 big stamps. Okay. You don't have to do that. You can just guess and try. But I tend to like to do that. So then, if I'm doing that, I'm gonna say, well, what if I use my maximum? Then 5 times 0.43 gives me $2.15. And then if I check how much is left over, so 2.36 minus 2.15, get 21 cents left over. And there's no way I can get 21 cents out of 8-cent stamps. It won't divide in evenly. So I know that's not it. Okay, so I'll say, let's try going down. So what if we used 4 of the big stamps? 4 times 0.43 gives me $1.72. Then I'll do my total minus $1.72. See what I get left. That leaves me with 64 cents. And if you divide that one, 8 will go into 64, and it goes in 8 times. Double check it to make sure. There, that's 64 cents. If we add these two together, $1.72 plus 64 cents, we get $2.36. So that works. So I had 4 of the big stamps, 8 of the small.
How did you start these off?
Had to start, I did 2.36 divided by 0.43. And that just kind of gives you a cap on like the most of the big stamps you could use. If you wanted to start on the other end, you could say, what if I did one 43-cent stamp? Right? And then that doesn't work. So then you can just guess if you want to. But that's kind of, doing it that way is just kind of educated guess and test. Other questions on that one? Okay. All right. Well, that's it. That's it on the practice test. So those types of questions, will be the similar types of questions on the test. Yeah. Remember Friday's Hawks Day. And I will see you later.